Good morning and welcome to today's webinar, Amazon S3 API Advanced Features. My name is Tam Nguyen. I'm with Cloudian and I'll be introducing today's presenters. If you don't already know, Cloudian is a Silicon Valley-based startup specializing in software-defined object storage. Before we get started, I'd like to go over a few items so you know how to participate in today's event. We want the webinar to be interactive, so be on the lookout for polling questions in today's presentation, and also you may ask questions at any time during the presentation by typing your questions into the questions pane of the control panel. For those watching the webinar on demand, you can tweet questions to our Cloudian Twitter handle at Cloudian Storage. At the end of the presentation, please complete the post-event survey. Doing so helps us formulate presentation topics for future webinars. Now let's introduce today's presenters. I'm joined by Chris Evans, a technology analyst. You may know him from his technology blog, Architecting IT. For most of the last 20 years, Chris has worked as an independent consultant focusing on open system storage and most recently virtualization and cloud. And we also have Paul Turner, who leads marketing, product planning, and strategy at Cloudian. A storage industry expert, Paul has over 20 years of development and management leadership at top technology companies, including Oracle and NetApp. So let's get started. Chris, please take it away.
Thanks, Tam, and hello to everybody. Good morning or good afternoon, wherever you happen to be located. So let's have a look at our topic for today. We're going to talk about advanced features, and by that we mean some of the more specifics that come into the S3 environment, such as tiering, ILM, replication, and multi-part upload. But before we do that, we'll have a quick chat and set the scene about what AWS and S3 is, and we'll give you some background. So let's go and have a look at that now. So what is AWS? AWS stands for Amazon Web Services, and as you can imagine, it comes from Amazon, the global retailer, Amazon.com in the US or Amazon.co.uk or wherever it happens to be in your region or your location. The service was started in around 2006, and the offering is basically public cloud services, and these are based on the standard NIST definitions we probably hopefully all know around scalability and service-based offerings and so on. So to date, the reporting of the returns of AWS have not been released, but from April 2015, Amazon decided to split them out because of the size of the revenue, and we can see that the actual size of AWS now is something like, when we did this presentation, in fact, $7.3 billion annually, with around 1 million active customers, and that accounts for something like 8% of Amazon's revenue. I think currently we'll probably see Amazon heading towards a $10 billion run rate going.
Yeah, actually, Chris, they just announced over $11 billion in their.
Wow. Okay, there we go. Yeah, so it's one of those things that every time we put it in a presentation, the data is out of date every single time. Thanks, Paul. So AWS offers multiple services, now around 70 and 13 major categories. We'll have a look at that on the next page. And each of those services is offered in many global regions around the world, and we'll very briefly discuss what that means in a moment too. So what sort of services can we see that are offered by Amazon? Well, very quickly, you can see from the screen, which is pretty tight in detail and not the best to read, but you can see that services are divided into things like compute, storage, database, networking, and so on. And they're a mixture of infrastructure as a service, there's some platform as a service features in there, and there are some enterprise applications like workspaces and docs and mail, which probably fall more into the software as a service category. In terms of how these are delivered, we talked about regions and zones, and globally now there are many regions for AWS. See that a lot of them are based in the North American continent, but there are some in South America, Europe, and the Far East and Australia. Within each of those areas, you'll also see that within the circle there's a number referenced there, and that's the number of availability zones. So Amazon protects their environment by deploying equipment across multiple data centers or zones. So if ever any one data center or zone had an issue, you should expect the others to be able to take over, and resilience is built across them. We're seeing that Amazon is continuing to deploy more and more data centers as their services grow, and S3 itself as a solution is definitely one of those key components. So let's let's move on and talk about what object storage is, because we're here to talk about object storage specifically as that feature of AWS. Well, object storage is a way to store unstructured data, and that could be files, could be objects, but anything that is delivered as a binary file, a binary object. And the idea of having an object store is that we can build something that's much more scalable compared to the traditional way we might store data in a file system or with block access. When we actually store data in an object store, we store it with metadata, and that metadata will either tell us when we stored it, when we created it, the size of the object and so on, which would be the system type data, or we can add our own metadata that helps us supplement information about that object itself. We may add information, for example, to say which application updated it, or which user stored the record, or something like expiration dates, or anything else that we might find would prove useful to understand how to use that content going forward. Object stores have traditionally been used for long-term retention, so you see them being used for archive and backup. And that's changing to a certain degree, I believe, and we're seeing people use them more generally, but that's certainly where the technology started. But because of the way that we access, which is across the networks over IP and potentially over both local and wide area networks, an object store gives us the ability to store data that could be accessed by a very disparate application spread across many locations. Compared to traditional block and file, of course, there are slight differences. So, for example, we see that we would have latency issues compared to typical block and file access. But that's the nature of what object stores are. They're not trying to replace typical block and file technology.
Yeah, Chris, just to speak to object storage, one of the things we're seeing is increased kind of active archiving or an active object store, where not just is it storing the data, but it's used as a streaming media environment, or as a content store for medical records and images. So you're seeing much more kind of active use. Definitely distribution plays a huge part into this, but also the efficiency of being, or the efficiency effectively of being able to store the data in native form as an object.
Yeah, thanks, Paul. I think the medical example is a great one, because typically the sorts of files and content that are produced in that arena wouldn't necessarily easily be deployed or stored on a file system, and it makes sense to have some sort of repository to put it into, and hence the need for object stores. So let's move on and talk a little bit about S3 itself. Okay, so S3 was introduced in 2006 in the US, and into Europe slightly later than that. And as we've already said, it's a repository for storing binary objects. And in the case of S3, this is done by referencing an object name. So systems use object IDs when you store an object. In Amazon's case, you can actually specify the object name you want to use. To date, the capacity of the system is well into the trillions of objects. The last published figures were probably 3 years ago now, when we talked about 2 trillion objects, and even at the time, the capacity was doubling every year. So we know it must be in the region of 8 to 10 trillion objects now, with millions of requests per day. Very differently to block or file access, we access an object store in S3 specifically using web-based HTTP protocols. And these can either be in the form of a direct call. We could actually code the HTTP call up manually. Alternatively, we could use software development kits, and there's some standard ones there around Ruby, Java, etc. And these basically allow us to package up the call we make, so we don't have to actually code the entire HTTP headers ourselves, which obviously makes a big difference. Because the platform is managed by Amazon, features like data protection and so on are actually managed internally. So the customer, the end user, never sees those features directly. They place their data on the system, and it gets the level of availability that's offered by Amazon themselves. Write data into the archive, and how do we get data out? Well, as we said, we use web-based protocols, and these can either be REST, which is a standard connectionless protocol where you make an individual call and you get a response back, or traditionally we could have used SOAP or even BitTorrent, but the SOAP protocol is actually being deprecated, so we're not going to have that in the future. We have three main ways of doing things, 4 if you include delete, and we use the put command for writing things, we use the get command for reading things back, and we can use the head command for doing information retrieval, so finding out information about objects or searching. There's also the delete option for taking objects out of the system. When we code up a request, we code up the request in the headers of the HTTP call, and we'll see some examples of that going forward. And if we supply data, like we're storing an object, then that will be in the data body of the request. If we're doing a request that reads data back to us, then obviously the request back from the HTTP call would give us that data back. As part of that call, we encrypt some credentials there that give us access to the system. That's something we discussed on another podcast. You can go back and find that on the website afterwards. But we build our credentials that allow us to get access to the system, and we either get return status codes that tell us our request has been successful, or we get something that tells us that it hasn't, depending on what the request is. So it's a very simple process to get data in and out of the system. So let's talk now about the main part of this presentation, and that's to talk about advanced features. We'll cover 4 features, and plus a 5th one which is not on the slide, and that's versioning, tiering, replication, logging and billing, and multi-part uploads. Let's go straight into the first of those, and that's versioning. The idea of versioning is to allow us to keep multiple objects or multiple versions of an object within S3. Now, clearly, if we have the ability to store objects and overwrite objects, there is a risk that we could store an object one day and store it another day, and we could overwrite what we already have, and that may not be what we want to do. So the ability to keep multiple versions allows us to create an archive, an audit trail of versions of that object as we've changed it. You can imagine if we were storing medical records or files or some sort of data that changed on a regular basis, the ability to go back and look at a previous version obviously would be very desirable. It also allows us to protect against things like accidental deletion. If we delete an object or overwrite it, either directly because we've made some mistake or because we have some sort of application failure or code problem, then clearly it's good to be able to go back and get a version back. When we, sorry Paul, go ahead.
Yeah, what's also nice about the versioning, I mean, just speaking about retrieving objects, is the end user is able to do that themselves. So unlike a backup where you have to actually get somebody else to get involved, in a version-based system, you can actually just go back and retrieve your older objects or your older file that you need, and so it's much more user-friendly as well.
Yeah, that's a good point, and I think self-service is a really nice feature to have in any system. Certainly in the object world, that is definitely one positive benefit here. All of our objects have object IDs, so this is the file name that we've already stored it. And if we're using versioning, we also have a version ID associated with each object. If we don't use versioning itself, then that version ID turns out to be null, but it is actually stored there with every object. A version ID is actually a uniquely random generated character string of up to about 1,024 characters. So you don't create those yourself, S3 will create them on your behalf, and then you just need to keep track of them. Let's have a look at how that works. So versioning is actually enabled at the bucket level. So a bucket is a big storage pool of resources that we've grouped together for maybe operational purposes like one department or one application. So we turn versioning on at that bucket level. And we have 3 ways of doing that. We can actually create a bucket and never have that bucket using versioning, in which case we call it unversioned. If we enable versioning on for that bucket, then obviously we call that versioning enabled, but we can't then turn it off. We can only end versioning at that point, and we have something called versioning suspended. So once it's turned on, it's turned on. You can't go back and turn it off. So let's try and visualize that and give you an idea of what that really means. So imagine we have a file and we want to store that file a number of times. Every time we store that file, each version of that file will be stored on the system, and the system would generate a version ID for us. Now, in our example here, I've just used very simple version IDs, just created something that's 5 characters. But as you can see at the bottom here, version IDs are pretty complex and they're quite long in terms of what they look like. So the version ID you get back from Amazon is unique and is quite detailed. What do we need to consider when we're actually using versioning? Well, if we do a read request, a get request for an object, now obviously you're going to get the most current copy of that object if you don't specify version ID. That's what you're going to get first. If you want to retrieve a previous version, then you specify the object ID and the version ID you want to bring back. And if you try and read an object that's already been deleted, unless you include that version ID, you'll get an error. And that sort of makes sense, because if there's no version ID supplied, it's assumed that object has been deleted, even though there might be old versions still there. You can the same process, by the way, applies for retrieving the metadata in those terms as much as it does for reading the actual data. We can actually take a copy of a version and move it. So we could copy a version to being the current one using the copy process. Or we can, I think we've already discussed this, but when we use the put command, we get returned a version ID. And obviously it's up to us what we decide to do with that version ID. We could store it for future use so we know which is the current version. Okay, let's go on and talk about tiering and ILM. Now, tiering is a pretty standard thing that we do in data storage, and really the reason we did tiering in the very first place was to make sure we could place data on the most appropriate media for the cost of the media and for the purpose of what we needed that data to be doing. And in a lot of cases, we know that as we write data to a system and that data ages over time, we know that the value of the data goes down and we tend to potentially access that data less. In the first few weeks, for instance, of a backup, we're much more likely to restore from that backup. Over time, we're much less likely over the coming months to actually come back and look at that backup. And it's the same with primary data too. So tiering gave us the ability to look at the actual storage we were deploying and place data on the most appropriate media, and therefore be more cost efficient about what we were doing with our data storage. ILM is actually, or as Amazon call it, Object Lifecycle Management. ILM is the process about how we actually move data between different types of storage through its lifetime. And in Amazon's terms, we have 3 platforms on which we can do that within S3. We have standard storage, which is the normal place that data will land when we write it to the S3 object store. That gives us standard data protection and availability, and we have a small table in which we'll show some of those numbers in a second. We have standard infrequent access, and this is for data that, as it's become less frequently accessed, can be moved to a different level of service in terms of S3, where we still need that performance, we still want to get to it, but we can tolerate slightly less service level because of the amount of the level of frequency at which we access it. We also have something called Glacier or Glacier, depending on which part of the world you come from, and this is Amazon's archive tier. This is a much lower performing platform, and the data profile is very different. So if we store data in Glacier, we don't get it back immediately. Although Amazon don't announce exactly how they're storing it, the chances are this data is being stored either on optical disc or tape, and therefore it does take some time to bring back. So Glacier is definitely the place that you would put your data in for long-term retention if you don't intend to access it very often. There is actually another option, and that's called reduced redundancy storage, and that's available for creating data that we can reproduce from something else. So imagine if we were storing a significant number of images on an archive, and we wanted to be able to create thumbnails from that. We would use RRS storage, because if we lose it, we can always recreate that data. And the durability of that is a lot lower than it is compared to normal storage. So tiering it, and
just a quick kind of comment on this. I think one of the things, again, that's interesting about Amazon is it's empowered by the S3 API, that your end user then has the control to basically set this lifecycle. I know you're going to show some examples. But for those who've been in storage for a while, we've been trying ILM for a long time, and most of the time we do it as a system admin function. And the system admin kind of knows better and will start archiving based on age or timestamp and do that and stub it or whatever we may do. But we're doing it from kind of the core IT group. What's nice and powerful about this is it lets the end users manage their storage and puts that onus back into the storage and makes it very easy for them to do it as well.
Yeah, I think that's a good point, Paul, and I think the reason that change has occurred is because ultimately storage administrators were in charge of managing the storage resource and trying to make it run as efficiently and as cheaply as possible. When we moved to S3, the cost of the service is now being pushed onto the customer directly, so it seems sort of reasonable that the customer should be allowed to move their data to the most appropriate level of storage. Although it seems obvious, I guess it's quite a sea change for people in terms of that mentality of who's got the control in that position. And as you said, that position of control has moved from storage administrators over to the customer.
Yeah, totally agree.
Change.
Yeah, it was change. Yeah, they didn't have access to the back-end system, but then costs are what's driving it, and cost is the encouragement for them to move. But I think as applied to enterprise IT, I think this change is actually really powerful too, empowering the end users.
Absolutely. And of course, that doesn't happen, as you said, it doesn't have to be public cloud that this applies to. It could actually be enterprise IT internally, if you have that capability. Okay, so let's talk a bit more about lifecycle. So within lifecycle management within S3, we use the lifecycle management functions to set policies on how we want our data to move between these tiers of storage during the lifetime of that object sitting on the S3 archive. We effectively build a set of rules. So we put together a set of rules, and these rules are effectively a set of actions, and actions that are taken on the data that sits in the bucket. And we effectively can do two things. We can either transition that data, and transition means to move, so we can move the data between tiers. And when we do that move, by the way, it's always down. So we're always moving to a cheaper or a less performing tier of storage. Alternatively, we can choose to delete, and in Amazon's terms, expire an object. It may well be that we decide once an object has been on the platform for a certain length of time, we don't want to keep it anymore. And that may be due to compliance policies or other reasons, but we do have that option to do that automatically. Once we set these policies up and apply them, S3 will run the policy automatically for us. And we'll come on to some of the parameters in a few minutes, and we'll see what some of those look like. Naturally, as you can imagine, that as there always are, there are some restrictions about moving objects. So as you're moving objects into standard infrequent access, you can only do that after 30 days. You can't move it immediately, so you can't put it there and use it as if it was primary storage directly. It does have to have been on the archive for 30 days. And clearly we've already mentioned that with Glacier there are some time-related restrictions in terms of how easy it is to get data back from Glacier. And there are also some issues there about when we bring that data back, how much we can bring back at any one time before we start getting charged. Obviously, we've talked about versioning, and clearly, with versioning involved, lifecycle management takes on a slightly different twist, and there are commands that work for the current version of an object and for the non-current ones. So you can imagine scenarios where we say, as soon as the current version is updated, as soon as we store a new version of that object, we might want to move all of the non-versions ones straight to a cheaper level of storage. And that could be a more cost-effective way of getting our data out of the primary archive. Again, all under the user's responsibility to make those decisions. So how do the different storage levels, how are they affected in terms of that, the tiering standards? And this one's quite interesting because I think it just gives us an idea of, before we go and look at cost, what do we get in terms of differentiation? Now, Amazon used two different measures here. I think availability will probably be very well known to everybody. The uptime SLA that they offer in terms of access to in terms of access to the data. 4 nines for standard, 3 nines for infrequent access, and no SLA offered on Glacier in terms of access times. You'll notice that there's a minimum object size on infrequent access. So Amazon has set a threshold that says unless your object is at least 120K in size, moving it to the infrequent access tier will not really save you anything. So we just won't move anything of that size. So even if you set a policy up, it just won't do it. And you can't move anything there until it's at least 30 days old. Similarly, you can't move anything to Glacier until it's at least 90 days old. Durability, let's just quickly talk about that. Durability is the same for all platforms, and this really defines our risk of losing data through having some sort of read error or some sort of corruption of that data at the back end. And naturally, that number is an incredibly high number, so the chances of ever losing anything is very insignificant, but it's the same on all platforms. So we shouldn't think because we move to a cheaper platform that we're getting less durability. We're just getting less availability in terms of the access time to our data. You'll see here that on first byte latency, the time to get to that object, we've already talked about this briefly. With Glacier, it's something like 4 hours to get to that first byte to start retrieving data. So there is an understanding that that is meant to be for long-term archive. So let's go and actually look at some lifecycle examples and see how we'd actually do this. So we've talked about lifecycle as a set of commands within S3, and we briefly mentioned that lifecycle definition applied to buckets. We can do 3 things within these, within the setting of our definitions. We can set the definitions. We can use issue a put command, which will set the definitions or overwrite them. We can do get on a bucket lifecycle policy, and that will retrieve them all for us. Or we can delete them. We can get rid of them completely. We can wipe them out. When we define them, we define them using XML. I'll show you a couple of examples in a second. And within the XML, we can have many rules. I think that, off the top of my head, I think the limit is about 10,000 rules you can have in one rule set. Within the rules, we have various parameters. Some of we've got here in examples, but they allow us to, for example, prefix the set of objects we want to apply the rule to, what action we want to take, what storage class we want to move it to, and so on. So all of those parameters set the definitions within our XML. Let's have a look at them and see how they look. So I put an example in here of setting the rule set, and actually I've kept it as a very generic one. We'll see a real example in a second. But the items in red show you the parameters that we set. So if we issue a lifecycle configuration command and we set a rule, we have to give the rule an ID, and we can make that something up that makes sense to us. It's up to us to set that. It could be a number, it could be a definition, it could be an expression. It'd be something that we can easily remember. We can set a prefix, which allows us to say set a definition around the type of files we want. We can actually within the name of the file have what looks like a directory structure, although it isn't. So we could say everything in the production directory effectively, or everything prefixed production could be included. We have to set whether the rule is active or not active. It gives us the option to take rules out of operation. And if we were doing a transition, we can say when we want that transition to take place in 2 ways. Either we can set the date explicitly and say it has to happen on a certain date, or we can say it happens a certain number of days after we create the object. As an example, we might say we transition everything after 30 days. And then we target the storage class, which is the target class we want to move that data to. You'll see there that we can code either a transition expression, or we can code an expiration expression. And in that one, we've just said after a certain number of days, expire that object, which means delete it. So we'll pick another example. which will help us understand it a bit more. And you can see here, this is the output we would get if we had issued a GET request, if we actually said we wanted to retrieve the current settings. In this example, I've highlighted in red again the similar items we highlighted before, and you can see that we've given this one a title, and it says archive the object and then delete. So it's the ID is called archive and then delete rule. We set a prefix that says everything in the project docs / prefix would be included in this. The rule's enabled, and what we're saying is that after 30 days we move it to the standard infrequent access pool. We then have a second transition which says after 365 days that object should be moved to Glacier, and that's 365 days after we have originally created it. And then there's another rule that says after 3,650 days, or 10 years, we delete the object. And each of those rules will be applied based on the time that we create that object and when it first enters the S3 archive. Now, obviously, we can create many rules and we can have them very different for different prefixes of object. So you can imagine we can build something very complex and very detailed in terms of lifecycle. A very advanced feature within the S3 environment. Okay, I'm going to pause just at this point, and I'm going to pass back over to Tam, and I think, Tam, you might have the poll to do.
Yep, so let me launch the poll question. All right, so the poll is currently open. The question is data lifecycle management and or information lifecycle management and or tiering something your organization has looked at to manage the influx of data? And then you can select from tried it, gave up, too much to manage, actively tiering data today, short-term plans, looking into it, or no plan so far. So currently, we have a lot of people, the needle's moving right now, but we have about 40% of people that are saying they're looking into it, and about 25% are actively tiering data today, but we still have a couple more people voting, so I'll keep the poll open for a couple more seconds.
It's interesting, Tam. We mentioned earlier when we were talking, Paul and I were talking about ILM itself, and ILM, I think, has been one of those things that's been very difficult for organizations to implement. And it's possibly because understanding what should happen to data isn't necessarily well communicated by the business. So it'll be interesting to see what results we get back from our survey here.
Yeah, I think so too. I mean, there's been so many attempts at it. So yeah. So Tom, do we have results off the survey? How does it show?
Yeah. So right now it's showing 4% tried it, gave up. It was too much to manage. 22% are actively tiering data today, and we have 7% who have short-term plans, and 48% are looking into it, and then we have 19% with no plans so far.
Okay. Interesting results, and I think it's great to see kind of the interest level around it. I think it's still very important as we grow data that we work out how to tier and to lifecycle data. I think, as Chris had mentioned, the fact that we now kind of empower the users to do it versus getting the admins to do it, I think is an approach that will prove powerful. It's interesting here that we had so few who tried it and gave up, because I think there's storage, there's a lot of baggage on ILM and the challenges with it. So hopefully this new approach will be a lot better.
Exactly. Great. Okay. Thank you, Tim. I'll carry on. So let's just talk briefly about some of the storage considerations on the two features that we've talked about already. Versioning doesn't include any customer-facing data reduction. So bear in mind, if you create many objects, that you will be charged for each version of those objects. Obviously, it will depend on which tier of storage you push them to, which is why implementing ILM or Object Lifecycle Management is a good thing, because otherwise you'll be charged an awful lot of money. But there's no benefit from anything that AWS may be able to do to either dedupe or compress an object or do something with it if you've only made a small change. So bear in mind you're going to be paying for all of that. AWS offers very much fixed storage tiers in terms of cost. I've got a slide in a moment where we'll just look at the cost. But they determine the tiering model. So you have to go with what they've decided. So you're within that requirement of 60 days and 90 days. You have to work with what they've set you. Naturally, we've already said it, but versioning and tiering work together. So you're paying an aggregate of the cost of the two of them. So let's have a look at the price. Oops, let's go too quickly. Let's have a look at that pricing then and just see how it matters, because it can be quite significant. You'll see here that what we've got is a list of prices purely for storage costs, because we've looked at the transfer and request pricing in discussion in another podcast, in another webinar. But so we've just got the storage costs here, and you'll see that as we increase the amount of data stored up to 5 petabytes, that the charge gradually reduces from around 3 cents a gig down to 2.75 cents a gig for standard. That's pretty good saving if you can move stuff to standard IA and then to Glacier. You can see that something like a 42% saving moving your data across to infrequent access. So if you are using policies, it can make it a lot more cost effective. But again, you're stuck within the boundaries of what Amazon have decided they think they can offer, and that's what you can work with. So let's go on and talk about the next feature now. Next feature we're going to talk about is replication. There may be scenarios where we want to move data from one region to another. We've already discussed that Amazon themselves protect data within a region, so you shouldn't have to replicate data for protection purposes, because that should be done. However, you may want to move data between regions for other causes, and that might include regulatory compliance, that you must have data in more than one place, or you have to have a physical copy in 2 locations that are geographically distant for some reason. You may want to actually reduce the latency of your application because you've got people accessing data from multiple places, and having lower latency makes more sense. Or you might want to just have additional copies for other reasons, like running analytics against a second copy or something. We define replication at a bucket level, so this is another policy we set. And all of the replication we put in place occurs asynchronously. So we don't really get to choose when that replication occurs. It's all done in the background by Amazon on your behalf. If we replicate data to another bucket in another region, all of the data, the metadata of that object goes with it. So you'll see identical creation times, owners, version IDs, and so on. All of that gets moved across. And because we're asynchronous, obviously we need to be able to look at a replication on an object and see what the status is. I've shown on the screen there the output of querying an object, and you can see that there is a parameter that comes back, as well as things like modified and length and so on. There's a parameter that comes back called replication status. In this instance, this particular object has completed replication and is replicated. However, the replication could be in a pending state, which means it's not completed yet, or it might have failed for some reason. So you really have to know that and go back in and look at that yourself. But those are the basic parameters around replication. So let's look at some of the considerations, and this is quite important really. If we're replicating data and we're using either server-side encryption or KMS managed keys, the data won't be replicated. Go back and look at the previous webinar if you need to understand what the different encryption processes are, but basically with those two you don't get the data replicated. It's important to realize that replicas are not an image copy, so the data in a bucket before replication isn't copied across, before you enable replication isn't copied across. So if you want replication to be on for a bucket, do it as soon as you create the bucket, so that you'll always replicate data. Anything that was there before won't get replicated. You need to make sure that the owner and the object and the bucket match up, otherwise things won't get replicated. And you can't do cascading replication. So you can't do A to B to C. You can't replicate from one region to another and onto a third one. That isn't supported. And remember, replication is going to increase your costs because you're storing an extra copy of the data.
Yeah, it's also important to note that versioning needs to be on for replication. I don't know whether you noted that, but that's important because they use the versions for replicating data.
Good point, Paul. I thought we had that on one of the slide, but you're right. Yes, that does need to be enabled. So let's quickly talk about logging. We can log some features within AWS using CloudTrail, which is another feature of the system, and that allows us to create effectively an audit log of the S3 activities. So we can track actions around configuring our environment. So when we create or delete buckets, when we set parameters on the buckets, and so on. It's very much it's a view of the changes in that bucket in terms of policy, rather than tracking every single operation that occurs. The data is written to log files which go back into an S3 bucket, so you can go back and look at those, and there will be a small charge for that. But you can see your data, and you can see what's changed within that. There's also the possibility to use events, and we can track what goes. Oops, I'm hitting too far ahead here. So you can also look at the status of objects that are created using events. So for instance, if you wanted to track when an object has been created in a bucket, you can create an event, and that can be then triggered off to something like the simple name service or something else like that. That allows you to, I guess, if you need to build a process around objects turning up into a bucket, say a customer puts some object in and you want to act on it, you can use that process to do so.
Yeah, and people are extending that with the ability to, as you said, do SNS kind of events or do Lambda triggers from it. It's a fairly extensive ecosystem now being built around the event side.
Exactly. Okay, so let's briefly talk about billing. Now, clearly we want to be able to track our costs, and we get extensive billing out of the S3 environment. All of the costs for a bucket are billed to the owner. The only exception being the fact that there is an option to do something called request to pays. Request to pays allows the person making the transfer in or out of that particular bucket to fund the cost of that request. The owner effectively pays the cost of the storage, though, but the requester pays for the transfer of the data. There's also the possibility to use DevPay, which is an option from Amazon that allows you to use their infrastructure to charge your end customers. That means you can use Amazon's billing and reporting process, and you can charge for data within the bucket. Very good for customers who are using S3 as a big repository for many customers' data, and they want to then automate the billing process to charge those customers themselves for the use of that storage. You can subdivide your billing, so you can do it using tags. Tags allow you to go into the content and put tags against directories or subdirectories and so on. And that's done by using a key value pair, so a tag and a value. They're very much user-defined, so you need to think about what you want to set up and make sure you keep those consistent across your environment. And there are some minor restrictions about what you can and can't use within there. But effectively, you'd use that as your process for dividing up your billing, maybe by department or whatever it is you wanted to divide your billing up into. So with that, at that point there, I'm going to pass over to Paul. And I think you're going to take the presentation from this point, Paul.
Yeah, sure. Thanks, Chris. So let me just make sure I can. There we go. So very quickly, you know, what do we do as Cloudian? Cloudian is actually an S3 compliant. For those who've been on these calls before, we're an S3 compliant object store. What's unique is we don't just store data in your premises as a scale-out object store, same S3 interfaces. But we also give this ability to tier up to Amazon. So you've got this hybrid storage capability where you can have your on-premises data center. You can have your objects managed there. You can decide on a bucket-by-bucket basis, which is the Amazon storage pool. you can actually decide which ones of those you actually want to move and archive data up to the cloud. So we don't just take S3, but we've also gone and extended S3. Down the bottom there, you just see it compatible against some other object stores that are out there. We spend a lot of time to make sure, and we also guarantee with our S3 Your Data Center guarantee, we guarantee our S3 compliance. And we work really closely to try to make sure that there's no application changes that you need to make from your side. So we want you to have the full power of the S3 interface. But even with S3, there's a few areas that we've gone and extended S3. And some of those, I'll explain why we extended them in a certain way. So the first is policy controls for data availability. In our system, I'll show you how we do this, but we have the ability to control on a per bucket level exactly how you want and where you want data to be replicated. In Amazon, you set the S3 storage, or you set an S3 redundancy, reduced redundancy storage, or you set an S3 with reduced availability or infrequent access. And Amazon governs how they're going to replicate between data centers. You don't have control of that. With ours, you've got the ability to actually control where you're going to place data, and I'll show you examples of that. For lifecycle policies, same things are supported as Amazon. You can tier to S3 or tier to Glacier, but of course now you're doing hybrid cloud tiering. You're actually tiering from your data center, which is where your primary S3 storage is, and you're tiering up to the Amazon storage. And so you've got a hybrid cloud tiering capability. For replication, we've extended S3 CRR, which is the cross-region replication, and most importantly, looking at it from a recovery side of things. And billing and rating plans, a little more cost-effective kind of, or flexible options for cost accounting, the ability to set different rating plans, because Amazon's is a fixed rating plan. They have a service that they make available as a service to everybody. We give the ability for service providers or internal IT to actually set their own rating plans. And then the last is admin APIs. All of the interfaces that you manage through Amazon, of course, are you go into Amazon's management console, the online console, or you interact with it through the S3 side. But through the admin console is where you actually get to manage the functions themselves as an admin or an IT department. And we've extended some of the APIs to do some of those management features. So let's jump into it really quickly. Per bucket protection policies. So what we allow you to do is to set up as an IT department, as an administrator group, as a group administrator perhaps, set up a policy that dictates exactly where you're going to place data. So you may set up the cluster to actually have a London region and a UK, a London, a Germany, and a New York region. And you may decide that data for the New York region should stay within the New York region and never move beyond those confines. Or you want to actually have data that gets replicated from London to the Germany region because you want to actually share data files across those two instances. And so you can set those up as policies. And the policy dictates exactly how we're going to share the data across data centers, which data centers it will be located to, and what type of protection. There's two types of protection. You can use erasure coding, or you can use replication for the data. And so you've got much more governance. Once you set these policies, they're one time, and every bucket that uses that policy is then, it applies to that bucket and all data within that bucket. But you can set a number of these different policies. So very good for governance and control so that you can make sure that data stays locally within particular regions. Very good for being able to govern different types that maybe need different types of availability and how many different copies you need of that data. But you do that by coding one of these policies. And just like Amazon, the way that you set that, sorry, just one sec. Yeah, just like Amazon, the way that you set that is actually by setting a storage class for the data. And based on setting the storage class, you can see here we've actually got it set as a standard class. It's just going to use the standard policy that we ship with. But you can actually go and set different classes of data, and you just set different policies that you need. Another example is hybrid cloud tiering. I touched on this, that Amazon gives you the ability to do lifecycle policy, and to do that lifecycle policy between the Amazon S3 or Amazon Glacier, and being able to move data between different types of availability zones that they have. We do a similar thing, except we're also extending where we're able to do that tiering from your on-premises data center, where you may be running Cloudy and HYPERSTORE, and to tier it up to Amazon S3 and Amazon Glacier. And the way this works is exactly the same as Amazon, so it doesn't look any different. You'll see down here we're actually setting a storage class here to be Glacier. We're setting the days to be at 90 days on the transition rule, and that's a rule then that will be applied on the data as it's transitioned. You can set this up at the S3 API call level, like we show here on the bottom right, but you can also set this up in our UI as a bucket policy. So you can set the lifecycle policy of how you want to move data to the cloud. And then everything that gets populated into that bucket will get tiered up. We'll follow that lifecycle policy. If that lifecycle policy says archive to Glacier after 90 days, then that's what will happen to all the data within that bucket. So what's nice here is that you've got the ability both to do it from the S3 command interface, but also from the UI interface. So cross-region replication, this was touched on by Chris. Very powerful capability. As we mentioned, it needs versioning on. You're moving data, so all new, puts, gets, are, puts on data. All of those are, of course, going to get propagated over to the destination here shown over in the UK there. But what's important is deletes are not. So you're not going to be propagating deletes. So a compliant store where there's a separate storage area where all data is kept forever, all versions of data, and deletes are not propagated across that store. So an area that we've extended it is we've made it very easy also to recover that data. So we've given a set of basically tools that allow you to actually bring back a whole bucket of data and be able and start up a new bucket with all of a version set of data, maybe a timestamp set of version set of data from the replication store. And this has been supported since our HYPERSTORE 6, which is our current release of the product. Billing extensions. As I think Chris showed earlier, Amazon has a set of billings. They've got these fixed price billings where, it's 3 cents. I think everybody knows the 3 cents a gig for Amazon S3. And although it is prorated based on or declining as you use more data storage, but then, of course, Glacier is down at 1 cent a gig or slightly below that, and again, based on data. But it's a fixed billing from Amazon. So what we have added into HYPERSTORE is billing extensions and rating plans. This allows you to set up for a group of users. You may have multiple groups of users. Just think of it as, your own internal cloud, and you've got get the marketing department and the engineering department. You might set up different billing plans for the marketing department based on them needing to distribute data using a policy that distributes data across 10 different sites. And so their cost of storage might be more expensive than the engineering site who's keeping it only at HQ. And so setting a billing policy or a rating plan that actually shows the cost of that storage, whether you're going to actually do a hard cost allocation out to end users or just a soft visibility view, is very desirable. This is also useful, of course, for service providers who may want to implement a storage service. The ability for them to set rating plans and set different rating plans based on different groups of users or different subgroups. So it works the same as Amazon otherwise, just a settable ratings plan. So as you see, this is just a sample of how you would retrieve usage data or post-usage data for particular users. So this is just a pullback. I mean, we log all of the data around what operations are happening, what's the amount of data that people are using. And so you've got complete logging of all of their activity. And so you can get really nice roll-up reports in very simple command-level interfaces as shown here. And then I touched on admin functions, that through Amazon, many of those admin functions are actually driven through their interfaces. You log into Amazon AWS, AmazonAWS.com, and you manage your functions from there. We've extended this because we need to have IT departments able to do API access, but you're able to control all of the configuration, all the multi-tenancy, our quality of service capability that we've reviewed in the previous webinar, the group-based ACLs also reviewed in previous webinars, and even the provisioning. So when I want to provision users or tenants, all of those can actually be done through the UI or through the S3 API and the S3 interface with the extensions that we put in. We've also extended to put in compression capability and, as mentioned, the per bucket protection policies. So over on the right there, you'll see that the multi-tenant services, you've got APIs that are more cloudy, and S3 is the blue there, and you'll see that there's a piece on that diagram that actually moves outside of the Amazon circle, and it touches on things like quality of service, dashboard, monitoring, admin APIs, all available via API calls and S3 extensions. And we package our product, just so people know, we actually package the product as software or full appliances. And most recently with Amazon, we actually have put in place a storage service tier that's available from Amazon Marketplace. So working very closely with Amazon on this, you've got the ability to actually go to the Amazon Marketplace, sign up for a service, and then you can actually implement an S3 store in your data center, basically a hybrid S3 store, which will run in your data center. It'll be charged and billed back through your Amazon bill, and it's an on-demand billing. You're charged, you pay-as-you-go model, just like the Amazon service. So you now have a pay-as-you-go model service that you can sign up for in your data center that tiers up to Amazon, or you can buy the full-featured software and hardware. Actually, all are full-featured, but you've got a choice of how you want to deploy the product. Maybe with that, we'll just see if there's any questions. We've got just a couple of minutes left. So, Tam, any questions that came in?
Yeah, we have quite a few questions. We'll try to get to all of them before our time slot. And if we don't get to them, then we'll reach out to you directly. So first question here. I think this is for Chris. And I'm just going to read the question. Is there multiple consumers changing the LP rules? Each have their own rules. How should they make okay, sorry, I'm trying to read this question here. If there are multiple consumers changing the LP rules, each having their own rules, how should they make sure that they're not stepping on each other's rules as the granularity of changes at the LP level with the get and put?
Yep, okay, understood. Well, first of all, the first piece to say is that clearly whoever comes in last will get their values saved. So if you do an update, somebody else comes along 2 seconds later and does theirs will get updated and they'll be the current ones. However, there are restrictions you can put in place. There are policies you can put in place that allow you to restrict users in their ability to actually go in and set the lifecycle policies at the bucket level. So what I would suggest is that you restrict that permission to only the people you want to actually administer the lifecycle policies. I know we said that it's great that everybody can do it, but in actual fact, you may want to designate one person within the business who has that responsibility, and then let them do all the updates rather than letting anybody in the business do it.
All right, so next question. A lot of companies in the UK are worried about data integrity, especially government data. How do you answer that question?
So I'll kind of jump in here. This is Paul. Yeah, I mean, I think it is a critical thing, right? And so, you know, just as you look at Amazon, Amazon's trying to deploy new data centers, and one of them will be in the UK. But it is something that we see in customers where they want to have some of their data, whether they're comfortable with the cloud or not, but some of it they may want to have in their data center, and that we give them this option. We give them a Cloudian S3 compliant store that they can run. They can now get it from the Amazon marketplace, and that gives them an option to keep data strictly where they want to control it. But Amazon's expanding all the time, so they do have, along with that, they have data centers that they're deploying, and as shown earlier, they are deploying one in the UK.
All right, and I think this next question is for you, Paul. Is there a limit on the number of bucket policies in Cloudian 6.0?
So, great question. There is a limit, and I don't know the number of them. I want to say it's at least, it's not just tens. I mean, it's quite a lot more than that, but I don't have the exact number. It's not in the thousands of bucket policies. That becomes unmanageable. We really want customers to manage, you know, to really look at their environment and manage to a smaller set of policies and govern their environment in that way. It's at least in tens, probably less than 100, and I don't have the exact number.
Okay, and then next question. For the lifecycle policies you mentioned, what attributes can it use to archive? For instance, like date or type?
Okay, so you're specifying two things. You specify a prefix of the object name. So if you've built into your object name some sort of hierarchy that includes what looks like a pseudo directory, although they're not really directories, you know, you could prefix everything that's a production file with production slash, then you specify the actual file in that sense, the object name as a prefix, and then you specify what action you want to take. So you then specify whether you want it to go after 30 days, 20, 50 days, whatever, and you can have more than one action within it in a particular rule. But you do it by prefix effectively, and either do it on an absolute date, or you do it on a date relative to the time the object was created. So if you store a new object into the archive today, you could have a policy that comes into action in 30 days' time. If you want to archive at the end of the year, and you want to move everything over on the 31st of December, you could make that the rule date, and it happens regardless of when that object was added in, subject to the minimums.
All right, and then next question, can I control data locality with the S3 API?
Sorry, can you what?
Can you control data locality with the S3 API?
Go ahead, Chris.
I was just going to say, the idea of the way that S3 is set up, you are pretty much restricted from seeing exactly how the data is stored and managed. So all you know is that you've stored it and created it in a certain region, and that's where your data will be stored, in that region. So if you want to store the data somewhere else, you'd have to retrieve that object and write it into another region, or use something like replication to move it elsewhere. You don't really get a choice physically about where it sits, if that was the question.
Yeah, I think it was, and it's one of the things that we've seen in enterprise companies that they want to have a little more control of that. So that's what we have extended with the data policies. There you actually get to effectively decide, like Amazon has S3 and S3 reduced redundancy, and they decide where they're going to replicate it. With the ability that we've added on the data policies, you get to actually decide which data centers or where you want to place data, as touched on earlier.
All right, so that's all our time for questions today. If we didn't get to your question, we'll reach out to you directly. Thank you, Chris and Paul, for presenting our topic today, and thank you to everyone for attending today's webinar. Don't forget to download the white paper and the content pieces provided for download, and also the slides will be made available to you within the next 24 to 48 hours. Thanks again for joining today's webinar, and have an excellent rest of your day.
Thanks a lot.